So I want to walk you through where the formula relating A, B, and C comes from in an ellipse, okay? Now this is not something you're ever going to have to reproduce or memorize, but it is worth seeing where does this formula come from, okay? So we know by definition that the distance, or rather the sum of the distances from a singular point on the ellipse to the two focal points is always going to be equal to 2a, the length of the major axis, okay? So what I have here is I have an ellipse. I centered it at the origin, okay? I don't know where these exact coordinate points are, but I know the distance from here to here is c units, and from here to here is c units. So I can identify these coordinate points as c comma 0 and negative c comma 0, okay? So I can identify those coordinate points as c0 and negative c0, okay? So c is just going to be some number, but we don't know what that is. Now I'm picking a point that's at a vertex because it'll have an easy x value for us to use because we're centered at the origin, okay? So this coordinate point up here, which is a vertex, is the point 0 comma b, because this is the minor axis, because this is a horizontal ellipse. So this distance right here is b, all right? So now what we're going to do is we're going to add in two lines connecting this point to the focal points, okay, to the foci, all right? And what we know, this distance, d1, and this distance is d2. Those distances are going to have to be equal to each other for this particular setup because this is C and this is B, this is C and this is B. These are similar triangles, okay? Actually, they're congruent triangles because they have two sides that are the same and it's a right triangle, okay? So this is side, angle, side, side, angle, side. These are congruent triangles by side, angle, side, okay? So D1 and D2 have to be equal to each other. And we also know that the sum of these two distances has to be equal to the measure 2a, or the length of the major axis, okay? So this is all coming from that definition of an ellipse. So now let's go through and do, we'll do D2 because that's a slightly easier one. So let's do the distance formula for D2. I could do the distance formula for D1 also, right? So that's the square root of the difference between the x values squared plus the difference between the y values squared, okay? So if I'm looking at D2, I'm looking at the point C0 and 0B, okay? So the distance between the x values is C minus 0. So this is C minus 0 squared. The difference between the y values is 0 minus b squared. Okay, so D2 is equal to the square root of, well, c minus 0 is c squared, plus 0 minus b is negative b squared is positive b squared. Okay, so I have that D2 is equal to c squared plus b squared. So here's where I'm going to go with that. We have that D1 and D2 are equal to each other. So this is also equal to D1. So now what I can do is I can say D1 plus D2 is equal to 2a. So the D1 is the square root of c squared plus b squared. D2 is also the square root of c squared plus b squared. And that is equal to 2a. All right? Promise we're going somewhere with this. Because there are two square roots that are identical, I can say that there are two square root of c squared plus b squared is equal to 2a. And now because there's a 2 on both sides, I can divide out that 2 and simply say that c squared plus b squared is equal to a. All right, but we know that formulas in general are easier to deal with when they don't have radicals involved. So what I'm going to do now is I'm going to square both sides to get rid of that radical. All right, so that's going to bring me over here. I'm out of space. Okay. So now I'm going to have c squared plus b squared is equal to a squared. Okay. Now, truth be told, because a squared and b squared are usually provided in a function or in an equation for us, we're going to make this say c squared equals. That's the convention. Okay. So I'm going to subtract the b squared over. So I get a squared minus b squared. This formula holds true for every ellipse. This is a formula that you want to make sure you have written down because you're going to use it in every single problem that you do. All right, if you know A and B, you can now figure out the value of C, and that allows you to plot those two focus points, which is something you're going to need to draw on every single ellipse that you draw. Okay, so what I want to point out is this looks a lot like Pythagorean theorem, but it is not the Pythagorean theorem because there's subtraction, not addition. Okay, so you can think of the formula for an ellipse is Pythagorean theorem with subtraction in place of the addition. Okay, a squared is always the bigger value because it's related to the major axis, the longer axis. B squared will be smaller because it's related to the minor or shorter axis. Okay, so that is the formula that relates A, B, and C. And again, you just need to know this formula and know how to work with it. You are never going to have to reproduce anything that you see here. All right, that's it.